Alright, today we're going to move on to 9.6, and we're going to be looking at tangent, cotangent, cosecant, and secant graphs. So those are what we're going to focus on today. Alright, so remember when we looked at sine and cosine, we first talked about, well, how do the sine and cosine function relate to the unit circle, and then we looked at how we can translate the unit circle into our sine function or our cosine function on the xy plane. Well, the same thing can be done with tangent. So how does tangent relate to the unit circle? Well, remember, tangent is y divided by x. And so if we understand that and we apply that to the unit circle, then we can see, or I'm sorry, we apply that to the xy plane, and we can see how going around the unit circle we can create a graph along the xy plane. Alright, so using the same demonstration that we did with sine and cosine, we can see how tangent develops. So if we have our unit circle here, and now we just said the tangent is y divided by x, well, what does that represent in terms of a graph? Well, that would be slope, because slope is change in y over change in x. So if we show the slope and we show the plotted slope as theta goes around the unit circle, then we can see what the tangent function is going to look like. And so these curves that we see developing, they look kind of like cubic functions. That is the tangent function. What it is not showing, because they're invisible, is that we're also going to have asymptotes separating each period of the tangent function. So if I speed this up a little bit more, we can see what happens in the negative direction as well. And so here, as it goes negative, now I can see that the main period, or I shouldn't say the main, but the standard period for a tangent function is this period right here. So tangent is the only function that when we're looking at one period of the basic tangent function, it actually has negative angles involved as well. No other function has that for one period of the standard function. Okay, so now if we look at the graph discovery sheet that I handed out to you in class today for your notes, you can start to see how some of these points develop. So here I have the sine curve in green and the cosine curve in red. So if I look at a particular angle, so for instance at the angle of 0, well, sine is 0, cosine is 1. What's 0 divided by 1? That's going to be 0. Here I know this is pi halves, so halfway in between is pi fourths. And I can see that the sine and the cosine have the same value. They cross there. Well, anytime you divide two numbers that are the same, you're always going to get 1. Here, sine is 1, cosine is 0. Well, what's 1 divided by 0? Well, that's undefined. So that's where we're going to end up with an asymptote. So I know that there is going to be a vertical asymptote here. If I look in the negative direction, right here at negative pi fourths, sine is positive and cosine is negative, but they are going to have the same value. One is positive and one is negative. So anytime you divide two numbers that are the same but opposite sign, you end up with negative 1. And then here at negative pi halves, we end up with the same scenario we had at positive pi halves, where we're going to be dividing by 0. So if I do negative 1 divided by 0, it's undefined, so I'm going to get an asymptote. And so from here, then we could plot other points as well, but they're not going to be nice numbers. So I can see this is one period of the tangent function. We could continue this on, so if I draw in the rest of the asymptotes, then I know these are my points. And over here as well. So that's our tangent function. Well, now let's talk about okay, well, what is the domain, and what is the range, what is the amplitude, what is the period? Well, the domain, if we look here, every time there's an asymptote, the function does not exist. So our domain is going to be all real numbers except x does not equal pi halves plus n pi. So if you're wondering, well, where am I getting this from? That's an asymptote, and then this is the distance between asymptotes. Sorry, that got a little sloppy there. So this is saying that it's all real numbers except pick one asymptote, usually the first one you start with. So I chose pi halves plus n. Remember, n just represents integers, and then the distance between asymptotes. So that's how we come up with the domain. So we're going to want to use that trick for cotangent, secant, and cosecant as well. The range, well, the range is all real numbers because this is going to go down to negative infinity and up to positive infinity. So negative infinity, negative infinity. Amplitude does not exist. Remember that our definition of amplitude was half the distance between the minimum and the maximum value. Well, if the range is all real numbers or negative infinity to infinity, there are no minimum and maximum values. Therefore, the amplitude does not exist. We are still going to have an A value. It is still going to affect the graph by being a vertical stretch or a vertical shrink. It is just not an amplitude when we're dealing with tangent. The period, this is something we discussed earlier. For tangent, the period is pi. Again, when we look at the generic function, that will change depending on our b value again. But for the standard tangent, y equals tangent of x, the period is pi. Alright, so now let's look at cotangent. So we could deal with cotangent by thinking of tangent because it's the reciprocal of tangent, or we can think in terms of sine and cosine, or x's and y's, if we're talking about the unit circle. But let's talk about sine and cosine. So cotangent is cosine over sine. So now here we have our cosine graph in red, our sine graph in green. So if I do cosine over sine at an angle of 0, well, that's 1 divided by 0. So now I'm going to have an asymptote at 0. Here at pi fourths, they have the same values, so that's going to be positive 1 if I divide to any two numbers that are the same. Here I'm going to divide 0 by 1, so that's going to be 0. Here at 3 pi fourths, they're going to have the same value but opposite sign, so that's going to be negative 1. And then again, at pi, I'm going to be dividing by 0, so that's going to be undefined or an asymptote. So now, again, just like with tangent, we could have plotted other points, but we can get the general idea of what the graph looks like. So just like with sine and cosine, notice that for tangent and cotangent, for one period, and that's what I've graphed here, I have 5 things that I'm plotting, and then I draw the curve from there. Now in this case, though, 2 of those happen to be asymptotes, but there are still 5 key points that I would plot, or that I would mark on a graph to plot one period. Notice that the shape of a positive cotangent graph is the opposite of a tangent graph, and vice versa. So this is the standard standard one period for cotangent. If we continue to fill in the rest of the graph, I'll draw in the asymptotes, and then the other points. And so there is 4 periods of the tangent graph. So now let's look at, well, what is the domain? And so we're going to have to use the same trick that we did before. So it's going to be all real numbers except x does not equal, pick on asymptote, so 0 plus n times the distance between asymptotes. You do not have to write the 0 there. You could just say all real numbers x does not equal n pi. I'm only writing the 0 to be consistent with how I did this for tangent as well. Range is the same as tangent. So that's going to be all real numbers, or negative infinity to infinity. Amplitude, just like tangent, does not exist. So that's dne, that's not 1. And then the period is the same as tangent as well, and this is something we discussed earlier. That's going to be pi. So that is the information for the standard y equals cotangent of x function. Alright, so now we're going to look at the generic function. So for tangent, we have y equals a times tan bx minus c plus d, just like we did with sine and cosine. And for cotangent, we have y equals a times cotangent of bx minus c plus d, again, just like we did for sine and cosine. Our graphing strategy is going to be slightly different now. We want to first find the starting x value, which is for both functions is going to be an asymptote, but how we go about it is going to be different. So this is tangent that I'm showing you here that I started to show you. So for tangent, we want to set bx minus c equal to negative pi halves. So this is our tangent column. The reason why we want to do that is, if you remember back here, when we looked at our tangent graph, I told you that this, which I've boxed in now, this period is the standard period for tangent, and it starts at an asymptote of negative pi halves. This is not the phase shift for tangent. If we want to find the horizontal shift, we would still set bx minus c equal to 0. So we set bx minus c equal to negative pi halves, and solve for x. That will be your starting x value, which is also going to be an asymptote. For cotangent, we want to set bx minus c equal to 0. And the reason why is here for the cotangent graph. Remember I said that this right here is the standard period for y equals cotangent of x, and that starts at an asymptote of 0. Now for cotangent, this is also the horizontal shift. But only for cotangent. Remember, for tangent, if we set bx minus c equal to 0, that will give us the horizontal shift, but that will not give us the starting x value that we want to graph. So we set bx minus c equal to 0, and solve for x. Next, we want to find the period. So to do that for both functions, that is going to be pi over b. So with sine and cosine, it was 2 pi over b. With tangent and cotangent, it's pi over b because the standard period is pi. So now we want to draw our new horizontal axis, which is still going to be d, and then we're going to plot points, which is going to be a distance up and down from the end. And then back up here, the interval is the same. That's not going to change for any of these. That's going to be the period divided by 4. Alright, so now we're going to start an example. We'll finish it in part 2, but let's go ahead with what I said to do first, and that is solve for the starting x value. So for tangent, that means we say pi x over 4 equals negative pi halves. So that's our bx minus c. C is 0 in this case. So if we solve this, the pi's are going to go away, and we're going to be left with x equals negative 2. So negative 2 is my starting value. Now let's find the period. And that's going to be pi over 4, which is going to be 4. Therefore, the interval is 1. Okay, we're going to stop there, and then we'll pick this up at part 2.